Welcome to Study Loop.
In this problem, we are given that there is a block, and this block is given initial velocity of 8 meter per second on an inclined plane whose angle of inclination is 28 degrees. And the surface here, this is having no friction, and we are required to determine its velocity as it reaches the top of this plane here. So let's say its velocity is v, which is what we have to compute, provided that u here is the initial velocity, that's 8 meter per second. And we have to also determine after this reaches the top of this plane, how far in the horizontal direction will it land right after it leaves the plane. So it's going to follow the curved path here, and we will find that. But before that, let's get the velocity as it reaches the top of this plane. So basically we have to get v first, and any object on this inclined plane, this will be retarded because of the component of gravity. So the acceleration due to gravity will be g here, and its component along this inclined plane, that would be g sine 28 degrees. So a here, that would be minus 9.8 times sine 28 degrees. So when we multiply 9.8 with sine 28, we get a here as minus 4.6 meter per second square. And now we simply use, so here we will consider h as the distance of this inclined plane through which this block travels. So let's apply energy conservation. So the total energy at this bottom point, that will be due to the kinetic energy, which is half into m into h square. And this would be equal to the total energy at this top point here, which is half m into v square plus the gravitational potential energy. So its height here, that would be h sine 28 degrees. So the gravitational potential energy will be m times g into h into sine 28 degrees. So let's just solve this equation. And when we do that, we get 32 equal to v squared by 2 plus g times sine 28 degrees, which is 4.6 into h. And let's mark this as equation 1. Now we simply use this formula here, according to which v square is equal to u square plus 2as. So when we put the values here in this equation, we're going to get v square as 8 square plus 2 times the acceleration, which is minus 4.6 times the displacement. So this implies that v square will be 64 minus 9.2 h. So these two equations, they are the same, and we see that it's important for us to know this h here, that's the length of the incline. So let's consider the length of this incline as 1 meter. So in that case, v would be 64 minus 9.2 and the entire root of this expression. So this gets us the value of v as 7.4 meter per second. And now we can see that this velocity is at an angle of 28 degrees with respect to the horizontal. So let's find out the horizontal component to get the second part, and that will be the initial velocity from this point. So it will be the 7.4 times cos of 28 degrees. So when we multiply them together, we can get the initial velocity in the horizontal component as 6.5 meter per second. And we see that in this case, in order to reach this point on the ground, it should travel a vertical displacement of h sine 28 degrees in the downward direction. So that displacement here will be 0.5 meters in the downward direction. And as we need to find here the distance in the horizontal direction, so this displacement is in the vertical direction, this initial velocity is in the horizontal direction, and the vertical component of the initial velocity, that will be this value of v that we have found times sine 28 degrees. So let's write uh and uv to differentiate between the horizontal and vertical component. So that would be 7.4 sine 28 degrees, which is 3.5 meter per second. And Now we can just use the kinematic equation s is equal to ut plus half at square. So this would mean that zero point 0.5 will be equal to 3.5 t minus 4.9 t square. So this implies that 4.9 t square minus 3.5 t minus zero point 0.5 would be equal to 0. And solving this, we get the value of t as 0.84 seconds. So in the horizontal direction, the distance it would travel that can be computed by using the same kinematic equation, and let's say that distance is x, so it would be equal to u times t, so its initial velocity in the horizontal direction times t here. So when we multiply 6.5 with 0.84, we get the value coming out to be 5.5 meters approximately, and that's the answer.